Good morning, everybody. All right, so today it's not going to be live interaction. That's okay. If you guys have questions, still feel free to reach out to me throughout the day. Also, if you'd like to join Zoom at this afternoon, I will send out the link for that. But again, this is pre-recorded. So if you guys have additional questions, I'm sorry I didn't get to them, just message them to me personally and I will respond. Otherwise, let's go ahead and hop into day 2 of the half angle identities. So you guys should already have the formulas. I did go through and went ahead and put the formulas on here as we get to the problems. The first one though is going through the proof. How do you even come up with that cosine of theta over 2 is equal to this plus or minus the square root of 1 plus cosine of theta over 2? Now remember, if this was a sine, then this would be a minus in between. That's the only difference. All right, so let's kind of look through what we have going on here. So here's what we're given. That's what we're starting with. And then it's saying, okay, well, and where did this come from? This is just our double angle formula, right? This is just our double angle formula. So that's what we're starting with, our double angle formula, 2x, and they picked the 2 cosine squared of x minus 1. Okay, perfect. Then the next statement is they're saying, hey, let this 2x just be theta. And if that's the case and you want to solve for x, then you divide both sides by 2, then x would be theta over 2. Done. So yes, liking it. So remember, we put for 2x, we plugged in that theta value. That's perfectly okay. This was the x, so we solved for x, and it's theta over 2. That's perfectly okay. That is correct. So then I look at the next one, I go, okay, well, how did we go from here to here? And I look and I see, well, there's this -1 here and the -1 here. So what did they do? Well, they brought this over to this side. Well, how do they bring it over to that side? How do you move that, get rid of the -1 from the right side? You'd have to add 1, right? If I add 1 here, what I add to one side, I have to add to the other. So -1 plus 1 would zero out. But this should be a +1. That's where your mistake is this number right here should be our +1. So if it's going to be a +1, then where is that error? It's here at that step number 5. That was wrong. And then you can see there's the +1, that's a +1 there, and you can finish out the rest of that proof by looking through it. So what I recommend is that when you guys go through these, just go through and kind of look at it step by step as if you're kind of solving it yourself. Otherwise it gets overwhelming. You're like, I don't know, it all looks good, right? So work it out yourself and think about what you're actually doing. And then I like to write on it and see, okay, well, what exactly is going on, make notes, and then hopefully you can figure out where that error is. All right, so moving on. For this one, they say between 0 and 2 pi, so I know I'm going to be using radians. And it says, what are the solutions to this? What are the solutions to this? So sine squared of theta is equal to 2 sine squared of theta over 2. So this is what we're looking for. All right. Well, let me kind of clean some of this up. I know that this is a half angle right here. This piece right here is my half angle. So this is going to be equal to, and look, I already wrote out the formulas. So this is going to be 2. That 2 isn't part of the half angle. Look, there's no 2 there, but this sine squared of theta is. So it's going to be 2 times your, actually, let me show you what this looks like. And sometimes it confuses you guys. Remember that this is sine of theta over 2 squared. See that squared right there? It's saying it's this whole thing squared. It's not the theta over 2 squared. If you just did the theta over 2 squared, you'd have theta squared over 4. So that's not what's happening. It's that quantity being squared. So this piece right here is what we have ran off to the side. So it's going to be 2, and what's being squared is this plus or minus the square root of 1 minus cosine of theta all over 2. It's this whole quantity. And don't forget that there's still this sine squared of theta. There's still this sine squared of theta here. All right. So I look at this and I go, okay, well, what kind of things do I know? Well, this is going to be a plus or minus and it's being squared. It's automatically just going to be a positive because a negative squared is a positive. So that's going to cancel out. I have a square root being squared. That's going to cancel out. It's gone. So I end up with 2 times 1 minus cosine of theta squared. Or sorry, all over 2, not squared, all over 2. And over here, I still have this sine squared. Well, now, here's the problem. Here's what I don't like about the sine squared, is on the right side, I have cosine. And so now I have sines and I have cosines, and I'd like to get everything to be in the same terms. So if I remember my Pythagorean identity, that tells me that sine squared theta plus cosine squared theta is equal to 1. If that's the case, then my sine squared theta is equal to 1. I can move this cosine squared theta over, so minus my cosine squared theta. So I could rewrite this as 1 minus cosine squared theta, right? This is just my Pythagorean identity. So this whole thing is equal to my sine squared. So that kind of helps because now I have things in terms of cosine. Everything's in terms of cosine. So I go, okay, well, can I clean this up? And I look, divided by 2, 2 times them divided by 2, it's going to cancel itself out. And now I have 1 minus cosine squared theta is equal to 1 minus cosine of theta. My next goal here would be to get everything so that it's equal to 0. Remember, when we want to solve an equation, we need to set it equal to 0. And so the way that I'm going to go about this is, I don't like it when my squared term is negative. So I'm going to go ahead and add cosine squared theta to both sides. And I'm going to go ahead and subtract 1. So I end up with, ooh, look, those ones cancel out. So I have a cosine squared theta minus cosine of theta is equal to 0. And then I could go ahead and factor out a cosine of theta. So I'm left with cosine of theta minus 1 is equal to 0. And remember our zero product property, I could take each one of these pieces and set them equal to 0. So cosine of theta is equal to 0. Cosine of theta minus 1 is equal to 0. So I want to know, when is cosine going to be 0? Cosine is 0 at pi over 2 and 3 pi over 2. When is cosine of theta going to equal 1? Cosine equals 1 at 0. So again, those values are just for my unit circle. So cosine is going to be 1 here at 0. And remember, it says 0 to 2 pi. This one says it can equal 0, but it cannot equal 2 pi. So that's how I decide which one is by what I'm given. So here's my value of 1. The other one, again, was at 0. So cosine is 0 at pi over 2 up here. And my cosine was 0 at 3 pi over 2 down here. So that's where these values are coming from. So these are going to be my solutions right here and right here. And so I match it up, and it's going to be this first one right there. Done. All right. So this next one says, what is the exact value? Could we use our sum or difference for this? Yeah, we could. There's more than one way to get to these, but we're practicing our half angle identities. So what does this mean? All right. Well, what does the exact value means? It's going to be something on my unit circle. And we know that 75 is not on my unit circle. So that's why we have to figure out a different way to go about it, because that value is not on my unit circle. So otherwise, I couldn't find the exact value. So here's what I know. If I want sine of 75 degrees, this value, that value is going to be my theta all over 2. And this value of 75 degrees is in quadrant 1, right? Because it goes up to 90. So we know that we're going to be, our answer is something that's going to be in quadrant 1. This is important to know what quadrant you're working in, because remember, it's plus or minus. So how do I know which one to use? Well, that's because it depends what quadrant this is. And if I'm in quadrant 1 and we're talking about sine, then we know it has to be a plus because they're all positive in quadrant 1. Okay, so let's keep on going here. Here's what I know. I know that my sine of theta over 2 is going to be plus or minus this piece. So if theta over 2 is 75, so my theta over 2 is equal to my 75 degrees, then what is theta going to be? Well, if I multiply both sides by 2, then this tells me that theta is going to be 150 degrees. Why is that important? Because when I go over here and I plug in my theta over 2, so my sine of theta over 2, which is my 75, right, is equal to, it's going to be a plus because we're quadrant 1. Sine is positive in quadrant 1. The square root of 1 minus cosine, and this is theta, not the 75 degree value. That's theta over 2. Theta is 150. So that's the trick for these. A lot of times you guys want to use this value that you were given. That's theta over 2, where I just want the value of theta. So divided by 2. So I need to just clean this up. So I know this is going to equal the square root of 1 minus, I go to my unit circle, cosine of 150 degrees is negative square root of 3 over 2. So 150 cosine is the x value. So this is negative square root of 3 all over 2 divided by 2. Again, we already said it's positive because sine in quadrant 1 is positive. So a negative and a negative is going to make that a positive. I want to make my numerator just one term, so I'm going to get a common denominator. I'm going to write this 1 as 2 over 2, right? 2 over 2 is the same thing as 1. I chose 2 because the denominator here is 2. So I end up with something that looks like this as 2 plus the square root of 2. Sorry, that's a square root of 3 all over 2 divided by 2. So if I'm divided by 2 here, remember if I'm divided by 2, this is the same thing as 2 over 1. So it's the same thing as saying I multiply by the reciprocal. So multiply it by 1/2. I would multiply by 1/2. So this is equal to then the square root of 2 plus the square root of 3 all over 2 times 2 would give me 4. Can I simplify this numerator? No. Can I simplify my denominator? Yeah, because the square root of 4 is 2. So that means I could rewrite this. The square root is just in the numerator, so it's 2 plus the square root of 3, and it's going to be all over 2. This is ugly, but you get to leave it just like that. You don't have to do anything with those double radicals. This is perfectly fine, just like this. You do not need to do anything, and it's going to match up with this answer right here. A couple more examples for you guys. Let me go ahead and flip. All righty. So my tangent. Here's my formula I'm going to be using. So I need to figure out what my theta is. So remember, I want the exact value. This isn't on my unit circle. That's not on my unit circle. This value, though, is going to be my theta over 2. So what is theta? If theta over 2 is equal to 5 pi over 8, then what is theta going to be? So I'm going to multiply both sides by 2. So this tells me that theta is going to equal 2 goes into 8 4 times, so 5 pi over 4. And why do I like this value so much? 5 pi over 4 is on my unit circle. This is great. All right, so my next thing is, well, what quadrant is this value in? What quadrant am I working in? Because remember, it's going to be a plus or minus here. It's going to be a plus or minus. So what quadrant is this in? Sometimes that's the hard part. So I know 4 pi over 8 would be pi over 2, right? And I know 8 pi over 8 would be pi. So it's between these two. So if it's between pi over 2 and pi, then I have to be in quadrant 2. So this value is going to be in quadrant 2. And if we're in quadrant 2, all students take calculus. If I'm in quadrant 2, then sine is positive, which means tangent has to be negative, has to be negative. So it's not what quadrant theta is in, it's what quadrant our original value that we're solving for is in. So this tells me then that tangent of 5 pi over 8 is equal to a negative square root of 1 minus cosine. We said theta is this value right here. So cosine of 5 pi over 4 divided by 1 plus cosine of 5 pi all over 4. And I could go to my unit circle and I could figure out what is cosine of 5 pi over 4. So cosine of 5 pi over 4 is negative square root of 2 over 2. So this is going to be 1 minus a negative square root of 2 over 2 all over 1 plus a negative square root of 2 over 2. So those are the same value. And I need to clean this up. So a negative and a negative makes this a positive. Remember that 1 is just 2 over 2. So this is just 2 over 2. So I could clean up both the numerator and the denominator. I could write them each as one term in the numerator, one term in my denominator. So this is going to be negative square root of 2 plus the square root of 2 all over 2 divided by 2, positive and a negative makes that minus square root of 2 all over 2. Now remember, if I have a fraction divided by a fraction, and those two fractions have the same denominator, what happens to that denominator? Yeah, they just cancel out. Gone. Done. So this simplifies to negative square root of 2 plus the square root of 2 plus the square root of 2, 2 minus the square root of 2. This is the answer that we are looking for. So I look to see which one of these does it match up with. So look at all the different combinations. These ones don't have the minus out in front, so you know it's not those. So check your signs inside, and it's going to be this very last one. So it is very important. You have to identify what quadrant you are working in. All right, this next one. Which expression is equivalent? Wow, this looks like a mess. I have no idea how to go about this, right? Well, this is kind of similar to that first problem we did over here where I had the sine squared and then I had this sine squared, that half angle. So we're going to be using this concept right here. Don't worry, just take it piece by piece. It looks ugly, but it's not that bad. So this right here, let me rewrite this. This is the same thing as saying 4 times sine of x squared. If you like to write it like that, it's equivalent. This is saying 8 times sine of x over 2 squared. Personal preference on how you want to write it. Now this one, I would probably leave it like that because remember our Pythagorean identity here that said sine squared plus cosine squared is equal to 1. That means that that sine squared is 1 minus cosine squared. So this piece right here, again, if this is just our Pythagorean identity, and this is going to be 4 times, and it's going to be times my 1 minus cosine squared of x, right? And then I have, oh, I see what they did. Okay, we'll come back to this. Well, I'll show you guys what they did in a second. So then I go over here and I look and I go, okay, well, then it's going to be minus and it's going to be 8. And then this piece right here, well, what is this? That's going to be this here. So it's going to be the square root plus or minus 1 minus cosine of x all over 2. Quantity squared. Now, when I square this though, that cancels out. The plus or minus has to just be a plus because again, a negative squared is going to be a positive. And so I have this idea of 4 and it's 1 minus cosine squared of x minus 8 times 1 minus cosine of x all over 2. And I look here and I go, oh, look, I could get rid of this fraction. 2 goes into 8 4 times. Some of you guys might distribute all this through. Let me just kind of, let's see, how do they, I see what they did. Okay, so you could do it one of 2 ways. So you could go ahead and you could choose to distribute everything through, or you could factor out that 4 in the end, because you can see that they pulled out a 4. That's a preference there. I probably would have just naturally distributed everything. I would have done that probably here, but they do factor it all out. So I just want you to be aware you could go either route on that. So I end up with then 4 minus cosine squared of x minus 4, a negative and a negative is going to make that plus 4. Oops, I didn't write my 4 there. Cosine of x. And these 4s cancel out. So I'm left with negative 4 cosine squared x plus 4 cosine of x. And then again, they factor out this value of 4. You can see that all of them are factored out. So if I factor out the 4, I'm left with negative cosine squared of x plus my cosine of x. And they don't write it as the negative first. So it just happened to match it with this one. It's going to be the same thing as this. Just when I solved it, I had the negative cosine squared first, but that's equivalent. So you can rewrite that negative cosine squared of x plus cosine of x is the same thing as cosine of x minus cosine squared of x. So personal preference there, they only have one option for you to choose that correctly. So however they decide to write it, that's the one you're going to go with. And my very last one, yay, we're almost done. All right, so I need to go ahead and I need to write which of these expressions is going to be equivalent. Basically, what does this simplify to? All right, well, again, we have this squared piece. This is 2 times, this is cosine of x over 2 quantity squared minus my cosine of x. So there's this squared means it's that whole piece squared. All I need to do is plug in then this plus or minus the square root of 1 plus cosine of x all over 2 is what's being squared minus my cosine of x. So again, we're just cleaning this up piece by piece. Do what you know you could simplify. All right, well, if it's a plus or minus squared, that negative squared is still going to be a positive. So no matter what, this has to be a positive. A square root and a squared always cancel off. So I have 2 times 1 plus cosine of x all over 2 minus my cosine of x. My 2 divided by this 2 over here, those are going to cancel out. And I have 1 plus cosine of x minus cosine of x. A positive cosine of x and a negative cosine of x cancel out. And I'm left with just 1. So something that looked so ugly cleaned up so nicely. So again, piece by piece, you look at the patterns. A lot of these were being squared, so you can recognize that. Remember some prior knowledge, your Pythagorean identities, sine squared plus cosine squared equals 1. That's the number one that you Pythagorean identity that you guys will use. I'm taking piece by piece. Again, if you guys have any questions, send me a message. Otherwise, you guys have a fabulous day, and I will see you guys tomorrow. Take care.